Okay, welcome to the second section of chapter 12. This isn't 11.3, it's 12.2. I forgot to change that on my notes, and this is on circumference and arc length. So, let's dive right in. Theorem 11.8 is talking about the circumference of a circle. Circumference is how far all the way around the outside of the circle. So what I always talk about is if you took a scissors and you cut this, and then you stretched it out and you measured it, that is what circumference is. Like, how long would that measure be? Okay, so you guys have probably seen this before. The circumference of a circle, we can think of it as two ways. You can take pi times your diameter, or 2 pi times your radius, because 2 times the radius, if you double it, that is our diameter. Okay? So, example 1, let's dive right in. We are asked to find the circumference of a circle given it has a radius of 11 meters. So, I'm saying there is a circle where I got to find the circumference. The radius is 11 meters. So, circumference is equal to, I'm going to go 2 times pi times my radius of 11. So this is going to give me, if I wanted this as an exact answer, this is 22 pi. And what would my label be? It's meters, because it's just a distance, okay? If we wanted to do that as a rounded value, which we typically do, I got to type it into the calculator here real quick. It comes out as 69.12 meters. Okay, 69.12 meters. One thing I do want to mention, guys, you cannot use 3.14 for that. Every calculator that you look at, whether you're using your phone or a scientific or something on the internet, should have a pi button. So use that pi button. Typically, we don't actually type that in until the end if I'm asking you to round. Okay, but we don't want to approximate it as 3.14. Okay, my next one, find the radius given that the circumference is equal to 18 yards. So circumference is equal to 2 pi r. I know my circumference is 18. I'm trying to find the radius. Okay, so I'm going to get r by itself, divide both sides by 2 pi. Divide by 2 pi. That gives me r is equal to 18 divided by 2 is 9 over pi. And that would be yards. Okay, that is the exact answer. Typically, we want to put that into an approximation, a decimal, and round. If you type 9 divided by pi into your calculator, that comes out as r is approximately 2.86 yards. Okay. Example 2, talking about skateboarding. So the dimensions of the skateboard wheel shown at the right are in millimeters. To the nearest meter, how far does the wheel travel when it makes 35 revolutions? Okay, so this wheel is spinning. I want to know how far does it travel altogether. So one full rotation of this would be that distance right there, which is just my circumference. Okay, so I'm going to start by finding that circumference. Now, my diameter on this one, if I look, I know that. It's 20 plus 20 plus 15 is equal to 55. This is in millimeters. Okay? We want our answer in meters, which we'll deal with here in a second. So, the circumference is equal to my diameter, or 2 times the radius, so 55 times pi. Okay? Now, that is on one revolution. I'm saying how far does it go in 35 of them. So I'm going to take this and I'm going to multiply by 35. So in 35 revolutions, this thing is going 1,925 pi millimeters. If we were to approximate that, it's approximately 6,047 point, what is it? Give me 1 second here. 1925 pi. 0.5657. So 0.57 millimeters. Now, I want that in meters. There are 1,000 millimeters in a meter. So what I would need to do is divide this by 1,000, which is going to give me approximately 6.047 meters. And I guess if we wanted, we could go 6.04757 meters. Okay. Let's take a look at this because this is the new thing to you guys, and this is on finding the arc length. So arc length is where you are finding a distance that is just a portion of the circumference. Now there's two ways of doing this. If you want to think of it as a proportion, which is what I'm typically going to do, we can say that the arc length of AB, so the part of the arc over the whole thing, 2 pi r, that's my circumference, is equal to the measure of arc AB over 360 degrees, because this AB measure is a part to a whole. The other way is to just take the circumference and multiply it by what portion you are looking for. Okay, now this is important. Arc length and arc measure are two different things. Arc measure, right here, measure of AB is in degrees. Arc length is like if you take a scissors and you cut off that portion, what is that distance in terms of whatever it may be? Feet, inches, yards, miles, it could be anything. So that is a distance. It's very important that we know the difference between the two. Arc length is a distance. Arc measure is the angle associated with that. Okay, so let's try a couple here. I want to find the arc length AB. So arc length, I'm looking for a distance here. Okay, the measure of that arc is 88 degrees because the central angle is 88. So I'm going to start with the part, the measure part over the whole part, 360 and 360. Excuse me, 88 over 360, because it's part to whole, is equal to the part, what I'm trying to find, over, now I got to think about what is this whole distance. Well, that whole distance is just the circumference, so circumference is equal to 2 pi times my radius, 2 pi times, I give you the radius of 2, gives me 4 pi. Okay, if we cross multiply here, this is going to give me 360x is equal to 4 times 88 gives you 352 times pi. So notice how I'm just tacking that pi on and dragging it along until the end. Okay, if I want to get x by itself, I would say x is equal to 352 pi, all divided by 360. And that, if we type it into a calculator, is approximately... Oh, my calculator shut off. Give me 1 second. 352 pi. Approximately 3.07. Be careful on your label. It should be 3.07 meters. Okay, this one would have meters. This is my exact answer. This is the rounded value. Okay, so first one was finding length. Now I'm asking to find the measure of arc S, so RS. So my answer should be in degrees here. So I'm really looking at what is this angle right here, the central angle, which is the same as this. So I don't know what that angle is, so I'm going to start off with X. That's what I'm trying to find. Over the whole thing in degrees would be 360. All of that is equal to the part. Notice that I tell you that is 38 over the whole. So the whole length would be just my circumference in purple. So off to the side, I'm going to say C is equal to 2 pi times my radius of 12.3, which is going to give me 24.6 pi. Okay. So I'm going to cross multiply. I've got 24.6 pi x. Notice how I have not typed it in times pi yet because that's going to lead to rounding errors. Is all equal to 38 times 360 gives me 13,680. To get x by itself, I need to divide by 24.6 pi, that's just a number. So 13,680 over 24.6 pi. You could have divided by 24.6 and then divided by pi, but you can just do it all at one step. Okay, now remember, we're looking for an angle measure here, the measure of that arc. So your answer comes out to be 177.0 if we go to the nearest tenth. The label on that is degrees. Okay, because we were finding the measure of the arc. So if you guys would like, try these two on your own, pause this, and then come back and give it or check your answers with what I do here. So first one, we're going to go part to whole. I'm finding the arc length. Okay, arc length. So I'm going to think part is 97 degrees. That's this measure right here because it's the same as that central angle, over 360 is equal to the part that I'm trying to find over the whole. So this is going to have to be circumference is equal to 2 pi times my radius of 4. So this is 8 pi. If I cross multiply and solve here, this would give me 360x is equal to 776 pi. This is going to give me x is equal to 776 pi over 360. If that was, or if I asked you to leave it as an exact answer, you would tell me it is that value, but you'd have to tack on that it is in feet. Rounded to the nearest tenth, we get 6.8 feet. Okay. Number 4, I now want to know the circumference. Okay, so remember, circumference is all the way around. I know that the part in red right here, so because I'm thinking part to whole, is 3.44. So what I would do is part 3.44 over the whole, that's what I want to find, is equal to part, I know that is 60 degrees as a measure, over 360. So this is going to give me 60x is equal to 1,238.4. I'm going to divide by 60. X is equal to 1238.4 all over 60. X is going to come out to be roughly 20.64 centimeters. Okay, so all the way around, I'm going to scribble that in red. The whole circumference is 20.64. I cannot stress enough, guys. It's all about part to whole relationships. And then just setting up a proportion. Okay, so example 4 here. I gotta look where I put my rounded value here. Okay, so we're looking at using arc length. We're gonna skip part 2. So you can ignore this 4 feet, and we're gonna think about this radius all the way to the outside is 8 feet. You'll see that on example 5, I crossed it out. It's the same problem, but they're talking about inside, outside. So example 4 says a conveyor belt for luggage at an airport is shown at the right. The outer part of the belt forms a 180 degree arc at each end. For each arc, the radius is 8 feet. Approximate the distance around the belt for a coin on the outer portion. Round to the nearest foot. Okay, so here's what I'm trying to figure out. All the way around this shape, I don't know why I keep using that color. I want to know all the way around this shape, how far does it travel? Okay, so I'm going to erase that, and I know right off the bat that from right here to right there is 20 feet. So here is 20 and 20. So I'm going to take 40 plus. Now I've got to figure out the part in pink here. I've got to figure out what this is. Now that pink value is going to be the same as this. So I can find one of those, and then I'm just going to double it. So off to the side, if we look at this, and we are thinking our whole part to whole, I know it's halfway of a circle. It is 180 degrees. So I can say 180 over 360 is equal to, so it's part to whole. I've got to find the distance, the part, over, I've got to imagine what this whole circle would be right there. So I'm going to say x over, this has got to be the circumference. So circumference is equal to 2 pi times my radius of 8. So this is going to be 16 pi. Okay, my calculator died again, so give me 1 second. 16 times 180 gives me 2,880 pi is equal to 360x. So divide by 360 and I get 2880 pi over 360. So 2880 pi divided by 360 gives me an x value of approximately 25.1. What do we need to round to? The nearest foot. So I'm going to go 25.13 for now. Let's erase what we got going on here just because I've shown you a whole lot. That 25.13, guys, is from right here to right here. It is part of the entire circumference, and in fact, it's half. So, what I need to do is go plus 25.13, but remember, it's the same thing down here. So I really need to double that. So you can either multiply it by 2 or just add another 25.13. So if we take that 40 plus 25.13 plus 25.13, we would get, it travels approximately 90.26, what are we talking, feet? It said go to the nearest foot, so we're going to say 90 feet. Okay, to tie this all together, number 5 is the exact same problem, so we're going to skip it, except it's looking at what happens on the inside of the track. But just to kind of rehash all of this, if I go part of the arc length over the whole arc length, remember the whole arc length is just circumference, is equal to the part, which is the arc measure, over the whole. A circle always has 360 degrees. Okay, that's the big idea there, ladies and gentlemen. So your homework is page 749 to 750, 3 through 25. You guys have a wonderful rest of your day, night, morning, whatever it may be. We'll